Right. Last week we were discussing about last week we were discussing about the networking part of the paper. Like we have discussed the question number 7. So let's continue from that. So we are going to continue from that, and we are going to discuss the remaining questions today. Okay, the question number 8. In the OSI reference model, the network layer is responsible for. So in the blank, you need to find the answers in the OSI reference model. Actually, we didn't discuss about the OSI reference model. Okay, regarding the question that you have sent to the chat, can you send it to the WhatsApp with the relevant paper? Then I'll be able to answer that, right? Just send it to WhatsApp with the relevant paper. I'll be checking that and let you know. So what can be done about that? Anyway, let's move to the paper now. So 8 question. It is OSI reference model. The network layer is responsible for this. So what is OSI reference model? Open system interconnect. OSI means open system interconnect. This is actually called ISO OSI. It's easy to remember, right? ISO OSI. It's a mirrored name. ISO OSI. International. Let's copy and paste. That is easy. International Standardization Organization Open System Interconnect Model. That is the long name, right? International here Open System Interconnect. International Standardization Organization. International Standardization Organization. So let's say meaning. Okay, ISO stands for International Organization of Standardization or International Standardization Organization. The Open System Interconnection is OSI. Okay. So let's write that. International Standardization Organization or International Organization for Standardization and Open System Interconnect. That is the meaning of OSI. Right. So then this is a reference model. This is not a real thing, but this is a reference model. That means when you look at a network, how network work and how network is basically behaving, if you try to explain that by referencing to something, that is called reference model. Reference is basically, it's not real, but you can just conceptually explain this using that reference model. It has 7 layers. The easy way to remember is all people seems to know data processing, right? All people, all people seems to know, right? Know data processing. So this is how we remember the layers. The first layer is application. Then you have the presentation layer. Then you have session layer, transport layer, network layer, data link layer, and physical layer. And there is a reverse way of remembering this. There is a reverse mechanism, a reverse way of remembering this same thing. OSI, ISO OSI model. The reverse way of remembering this is, you can say reverse. That means from bottom to top, you can remember using this. So the technique is, please do not throw sausage, pizza away. Please do not throw sausage, pizza away. please do not throw sausage pizza away. That is, please do not throw sausage pizza away. Physical data link, network transport, session presentation, application. If you remember from top to bottom, all people seems to know data processing, application, presentation, session transport, network, data link, physical. This is actually to explain how a network works, a conceptual model of explaining the functionality of network, conceptual model of explaining functionality of a network. So I'll write it here, a conceptual model. Model means not a real one, of representation, representing how a network will work. That is called ISO-OSI reference model. Please remember the short ways of remembering this, and also please write down this part. So with the tricks. Why the tricks? Because for the examination, you need these tricks, right? Otherwise, you will forget the order of the layers. So if you can just remember the order of the layer, just remember that application, presentation, session, transport, network, data link, physical, then you don't need to remember these words. But if you don't remember them, then just remember in this way. Bottom to top it is, please do not throw the sausage pizza away. Throw sausage pizza away. And if it is top to bottom, all people seems to know data processing. Okay, these are the ways of remembering OSI, ISO, OSI reference model. International standardization organization, open system interconnect model. It's a conceptual model explaining how a network will work. So what will happen? What will happen in this ISO OSI model? So what are the things working? You need to know, right? The things work in and things happen in these layers with the task. Application layer. Okay, have you finished writing? Have you finished writing or still writing? Okay, if you are still writing, tell me. Wish me, I think you need to join the audio. She disconnected for some reason. Doesn't matter. All people seems to know data processing. Okay, it's still writing, right? Okay, finish it, quickly finish it. Vishmi, can you hear me now? Hello? I hope you can hear me now, right? Because previously you have not joined with the audio. I think you can hear me now. If so, please indicate. Right? I think you can hear me now. What I asked you to do is please write down this. So what is this? We are going to discuss about our question. So I said that this is a theory revision class. We will be discussing theory and revision both. We will be discussing papers as well. What we are doing normally. So if you don't know what we are doing, we will go to the question and try to understand underlying theory of that. We will move to the question and try to understand the underlying theory. What is the theory behind this? Then it is easy to remember remember this, because when you watch this video, it will be very easy to you. You can just go through that and remember what we have discussed with the theory. Why? Because the next time when you analyze, right? When the next time when you analyze, it is easy to answer the questions because you already know the theory. Okay. I hope now you have finished writing. If you're still writing, tell me. I hope you have finished writing this. Okay, let's move and discuss. Right. In ISO OSI reference model, I would like to emphasize a small graphic. Emphasize a small graphic related to this ISO, and this is the one reference model. So see, this is very important, right? In the ISO OSI reference model, application layer is where we are interacting. අපි interact කරන්නේ application layer එකත් එක්ක. We work with the application layer, and this is where you can see protocols like application layer. You can see the protocols like HTTP website එකම අපිට පේන්නේ මේ layer එකේ. HTTP like protocols are working in this layer, right? Okay. So let me summarize and give you this, right? This graphic is important one, because it says what works in this layer. And there's another thing you need to know about this, the super summary. So is basically you need to remember this graphic. That is for number one thing that you need to do, because without that, you will not know what are the things working here. Let's copy the image. Why it's not copying? Okay. Then the next thing is you need to know. Here, it's copy. Then the next thing is you need to know what are the protocols work there. Right? Protocols, we have learned that, right? Protocols means what are the protocols? Protocols means the rules, set of rules. So different protocols you will work in different sections of layer. The different protocols are working. You need to know about the protocols. I think it's here. So different protocols are working in different layers. Yes, it is here. Okay, then you can see this is very important. Let's take a screenshot, right? Don't need to write down this. So later you can write down. For the moment, just take screenshots. That's enough. Different protocols are working in different phases of this layer. Can you see? Then wrap it behind the text, and then it will be easy. This one also wrap it behind the text. Okay. Let's crop this and send it like crop it, and then you can take a screenshot and one go එකපාරම ගන්න පුළුවන්. මේ layers ටික දැන් කොහොමවත් අතන තියෙනවා. You only need to know about the things work in different layers. Okay, this is how the things work in different layers. And not just that, then you have to learn the packet concept. Packet concept means how, so data encapsulated, how data is handled. I'll explain this, don't worry, I'll explain this, right? After that, you can understand this easily. I'll explain this, then you will be able to understand this easily. The data encapsulated this way, this is called the, so here in different layers, different names are given to the data, right? Then let's see how this will work, right? So in the application layer, we call application protocol data unit. Then presentation layer, we call presentation protocol data unit, and session layer, session protocol data unit. Transport layer, transport protocol data unit. Anyway, this is called PDU. Then in the network layer, you have packets. The data link layer having frames, and the bits are there in the bottom layer. So what is the meaning of this? You need to know. Then only it's easy to understand this concept. It's a very clear graphic. Okay. PDU, protocol data unit, packet, and then bits, frame, and bits. මේ ටිකෙන් තමයි ඔක අහන්න පුළුවන්. ඔය ISO OSI එකෙන් අහනවම තමයි. හරි. ISO OSI එකෙන් අහනවම තමයි. එතකොට මේ එක එක layers වල data තියෙන විදිය අහනවා. Right. මෙච්චර deep අහන්නේ. So don't worry, they will not ask this much of deep in depth, but you just need to remember how data is there in different layers. How data presented in different layers. You need to know that. Okay, let me explain everything using these three pictures. This is enough. The entire lesson related to ISOSI is here. Okay, what is the lesson? So there are 7 layers. When in the networking model, there are 7 layers. Again, අපි හිතනවා මේ network එකේ data යනකොට මට්ටම් 7කට data යනවා කියලා. We will think that there are 7 levels of data when we are sending data from one computer to another computer. Okay, one computer to another computer. There is one computer. When we are sending this data from this computer to another computer in another place, we believe that data is sent in 7 levels. 7 levels. Okay, in the topmost level, what we can see, අපිට පේන්නේ මොනවාද? We can see the end user layer is application, HTTP වගේ protocols, that is website, FTP like protocols, DNS like protocols, IRC means internet relay chat, SSH means secure shell. ඒ ටික මට දෙන්න බැරි වුණා. These are some protocols. So what is FTP? We discussed that last day. FTP is file transfer protocol. HTTP, hello. You need to answer. HTTP is, oh, come on today.
Hypertext transfer protocol.
Hypertext transfer protocol. FTP is,
File transfer protocol.
then IRC is internet
Relay chat.
Yes, internet relay chat. Chats and all these are working in IRC layer. IRC කාරයෝ කියලා කියන්නේ ඒගොල්ලන්ට නෙවෙයි. IRC means internet relay chat, right? IRC protocol means internet relay chat. Then there's another thing, SSH. SSH කියලා කියන්නේ, SSH means secure shell. Secure shell. ඒකෙන් තමයි HTTP එන්නේ ඔය SSH එක්ක HTTP ඇවිල්ලා තමයි secure shell. So this protocol. DNS means, that also we have discussed last day. DNS,
Domain name.
domain name system. DNS domain name system, correct. Okay. Hari then one of the open protocols, right? Then in the this is actually a presentation layer. Presentation layer, so there are like representation mechanisms. එතකොට ASCII වගේ ඒවා දැන් මෙතන දීලත් නැහැ. ASCII වගේ අපි ඉගෙන ගත්තනේ number systems වල character representation. එතකොට these ASCII, Unicode like representation, FTP, MPG. MPG කියන්නේ, what is MPG? JPG. These are file types, right? MPG, motion picture expert group, joint picture expert group, secure socket layer, American Standard Code for Information Interchange, secure socket layer, SSL, IMAP, Internet Message Access Protocol. MPEG is a like video format, video streaming, video format, MPEG, motion picture expert groups. Picture format එකක් JPG, joint picture expert group. These are basically presentation layer. Presentation layer කියන්නේ data represent වෙන හැටි and the encryption. So what we can see in the top layer, ඉතින් ඒට යටින් තියෙන්නේ මේකේ තියෙන අර data කොහොමද once binaries වලින් මේ data store වෙන්නේ. කොහොමද මේ data encrypt වෙන්නේ, binaries වලින් secure වෙන්නේ. So how the binary representations of the pictures, how binary representation of videos. Today we have learned that in our theory class, 2024 theory class, we have learned some character representation. All these happen in the presentation layer. The session layer is basically අතට දෙන layer එක, shake hand. So this is where the API, application program interfaces. APIs means, so let's say, so what is API? Do you know what is API? These things are really practical. We are combining them together now, right? API we have learned in operating systems and then systems. API, practical. API means one application need to talk with another application. How this application talk to each other is called API, right? API, application programming interface. Again, this, let's say one application is written in Java. So then let's say ABC software written in Java. Another software is there, let's say DEF website written in PHP, written in PHP. Now this Java application need to communicate with the PHP website. In between that, what is working is called API, application programming interface. Actually, when this, especially this happens when this bank transactions are there. There are two applications. See, let's see. Practically, confirm. Theory. Let's say you want to pay dialog bill. Right, I need to pay my dialog bill. Dialog can't reload that online. I'm going to this dialog website and start entering my data. See that this is dialog website. And start entering my data. Let's say I want to put reload to my mobile phone. Put in my mobile phone number, continue. I'm going to reload. So let's say I want to reload 1,000 rupees to this using my Visa card. Then pay it, right? Pay it. Okay, see here, it is representing to, it is now sending me to another website. Am I in dialog website or another website? Right? I'm not in the dialog website. I'm in here, secure acceptance, cybersource.com. Cybersource.com is another website. I want a dialog reload. I went to dialog website and start paying, and it has sent me to cybersource.com. Is it secure? Is it good thing? Can I enter my card data here? Is it legal? Is it okay? You have to tell me. Because initially I went to dialog side. I want to pay dialog, but dialog is sending me to this place. Pay and come. Is it good? Is it secure? Hello.
Yes, sir.
Yes, this you can believe. This is actually yes. You might think this is no. Hari wala danna wala ge addaki manu hiten pula meka varadi. This is wrong because there is another site appearing. No, this is correct. This is what the API. Because dialog they are not a payment company. They are not a registered bank to accept the payment. They will redirect us to a payment gateway. Right, internet payment here. This is by HNB, right? HNB and dialog. You can see the dialog and HNB. Because of their agreement, they are sending us to the particular IPG, internet payment gateway, and asking to pay. After payment successful, HNB do the verification and said yes, payment is deducted from this, and that will be deposited to dialog's HNB account maybe, and then HNB will confirm, yes, hey, we got the payment from the particular fellow, and dialog will authorize the reload. So then there is a deal between these two websites, because dialog is sending us to HNB, go HNB, pay and come, and HNB will get the payment and tell dialog, yes, I got the payment from this fellow. And dialog is approving us a reload. Actually, in order to work, we need such APIs. We need to work with APIs. So this is one purpose, but there are many other reasons that we need API, right? So here you can, if you search need of API, there are a lot of examples. API, application programming interface, because if you need to work with different applications like mobile applications, so here API integration you can see here. So this Google API will allow you to work with Google. Some website providing Google search, some website accepting Google payment. API for payment, that is what we saw now. Let me erase this. Let me erase these things. API for payment, that is what we saw. And API for OpenStack, API for Google linking, API for healthcare, API for databases, API for social media integration. You can see some websites allowing you to log in with Facebook, log in with Google, log in with Facebook. How? Because of the API. Log in with Google, log in with Facebook is possible because of APIs. So different applications developed in different environment, having different technologies, can interact with each other with these APIs. Okay, that is working in which layer? Again, that is working in third layer session. That is where the shake hand happen. Atata deala customers la hamben කරනවා වගේ තමයි. ඉතින් නිකන් මතක තියාගන්න ඉස්සලම තියෙන end user අපි දකින building එක. This is end user interface. It's the building that we can see. The presentation layer is like that, what bricks and walls and bricks, all these things are belongs to the presentation layer. That is the underlying layer. We cannot see that properly. හැබැයි ඒකෙන් තමයි ඔය building එක හැදිලා තියෙන්නේ. එහෙම තමයි data represented. Session layer is what is happening there. We go and interact with people, the session. Then the transport. Transport is the connection. That is where you go and talk. You shake hand, you go and talk, negotiate. TCP is, what is TCP? I have to do entire network lesson. I'm helpless.
Transmission control protocol.
Yeah, transmission control protocol. TCP is transmission. Then mama theory class එක කරත් මේ ටිකම තමයි කරන්නේ. එකම දේ my like person like my discussing order will be different. I had to do entire network lesson because of this paper. Anyway, you are lucky. Right? You are lucky because networking lesson is done from the beginning. But the order is different. We discuss everything. TCP is transmission control protocol. That is like buses having a route. Right? Buses having a route because that's but bus will definitely go on the particular road. 01 is Kandy Colombo Road. 06 is Kandy Kurunagala Road. Sorry, Colombo Kurunagala Road. 06. So that is the route. The TCP has a route. TCP ke data yavanapota. Yes, TCP ke data yavanapota route ekak thiyena. TCP has a route. So what it does? You have internet. Internet is a messy network. When you are sending from one person to another person, the TCP will build a virtual path from here to here. It's building a virtual path. We call virtual circuit packet switching. This virtual path is called virtual circuit packet switching. Because in the telephone network, you have circuit switching. Telephone network is circuit switching. So let's say you have a telephone. You have a telephone and you have another telephone. In this telephone networks, you have circuit switching. Circuit switching කියලා කියන්නේ මේ වගේ circuit එකක් හැදුනම ඒක කැඩෙනකන් තව එකක් හදන්න බෑ. ඒකනේ call එකක් එනකොට engage කියලා වැටෙන්නේ, busy කියලා වැටෙන්නේ. When you have a circuit, this circuit is permanently established. This is called circuit switching. You have different paths, but these circuits basically works together. The circuits are established. Maybe different connections, different. But at one time, there will be a permanent circuit. When specific time, when you take the call, there is a permanent circuit allocated for your call. This permanent circuit is allocated for your call. The other circuits cannot connect. That is why the busy tone comes. This is called circuit switching. Then in the internet environment, in the data environment, you have packet switching. Packet switching. Data wala thiyenne packet switching. So what is packet switching? Basically, you have small chunks. Small chunks called packets. Then api kiwe me vidiyath packets. Chuti packets thiyena. Small chunks called packets. These packets are sent through this network. Punchi kali walata kadala a packet තමයි යවන්නේ. දැන් මේ film එකක් කියලා හිතන්න. Think this is a film, but entire film is not sent. It will send small packets. These packets will go through this path. But there is a dedicated path. That is why this is called virtual circuit packet switching. Circuit එකක් වගේ හැබැයි මෙහෙමයි. මේ different paths වලින් packets යන්න පුළුවන්. At the same time, you can download film and download a software. Download film, download a software. That is possible. එතකොට මේක dedicated allocate වෙන්නේ නැහැ. This is actually TCP, transmission control protocol. TCP, it does transmission control protocol. එයා කරන්නේ virtual circuit packet switching එකක්. ඒ කියන්නේ එයා telephone wage, හැබැයි මේ circuit එක virtual. Why it is virtual? That means like anyone can take. Like while you are in downloading something, you can take a call. Doesn't matter. Packets will go. If there is a permanent route for the packet, that is TCP. If there is no route, then that is UDP. UDP is like a tree-wheel protocol. TCP is like a bus protocol. TCP can a bus wage, route එකක් තියෙනවා. UDP can a tree-wheel wage, route එකක් නේ. So what happens when you're communicating using UDP? Okay, I'll show that using a different color. When you're communicating using UDP, say you want to communicate using UDP, still you can communicate, but packets will go here and there. And ultimately, it will reach the destination. අන්තිමට එනකොට පිළිවෙලට එනවා. අර හැම යනවා. ළඟට එනකොට පොඩ්ඩක් ඔන්න කට්ටිය පිළිවෙල වෙලා එනවා. හැබැයි ඕඩර් එක වෙනස්. This is called UDP, User Data Ram Protocol. Tree wheel වගේ අර හැම ගිහිල්ලා අන්තිමට ඔන්න තැනට එනවා. හැබැයි TCP පිළිවෙලට එනවා. TCP is reliable, UDP is unreliable. TCP is sending data in a sequential manner using patterns, using a virtual circuit, but UDP is sending data whenever available, wherever available, sending data. So these green color packets are UDP, right? I'm writing in green color. This is UDP, User Data Ram Protocol. UDP, User Data Ram Protocol. User Data Ram Protocol. කොහෙන් හරි ගිහිල්ලා අන්තිම තැනට එන්න තමයි ඕන. Okay, now tell me some application. So YouTube streaming, what do you think? Is it UDP or TCP? YouTube එකෙන් වීඩියෝ එකක් බලනවා. YouTube streaming. Can it be TCP or UDP? So nature of UDP is what is nature of tree wheel? Tree wheels or taxis will go here and there, but ultimately it will come to the destination. It will be very fast. අර route එකේ එනවා වගේ නෙමෙයි ටිකක් වේගෙන් යන්න පුළුවන්. Yes, TCP is called connection oriented protocol. That is correct. That is the technical word in it. That is what I want to tell next. TCP is a connection oriented. Connection oriented means you have a virtual path, virtual circuit packets in this connection oriented. Connection. UDP is connectionless. UDP is connectionless. TCP is, in the other hand, connection oriented. Secure, reliable, ආරක්ෂිතයි, reliable, විශ්වසනීයයි, ආරක්ෂිතයි. It's a connection oriented. It has a virtual circuit packet switching, transmission control protocol. It is sending packets in order. It is checking for the acknowledgements, reliable delivery. You can trust it. It is secure but slow, because you need to always send using the same path. But UDP, in the other hand, is like private vehicles, taxis and all. That is fast, can follow any path. It is connectionless, therefore. Connectionless, because can follow any path. Connectionless, going here and there. That is not secure, that is not reliable. But sending for YouTube video or streaming YouTube video can be easily done with UDP. Why UDP? එක පැකට් එකක් දෙකක් මිස් වුණා කියලා වීඩියෝ එක සම්පූර්ණයෙන් පේන්නේ නැති වෙනවද? ෆිල්ම් එක අපිට බලන්න බැරි වෙනවද? If you miss 1 or 2 packets, still we can watch the movie. But sending an email, so what is preferred one? Is it better to send email using UDP or TCP? Hello? I'm sure now you are not sleeping, right? TCP. Why TCP? Because think 1 packet or 2 packet missing in email, then you are gone, right? 1 or 2 packets missing in email. Emails are sending secure information like passwords, user data, passwords, login information, credentials. All these things can be sent using email. Email need to be secure. You cannot miss the packets. But video streaming, maybe Zoom UDP can do. Zoom වල පොඩ්ඩක් හිටියේ ඉඳලා හිටලා කැඩි කැඩි ඇහි. එහෙම වුණා කියලා ප්‍රශ්නයක් නෑ. ඔයාලට ඉතුරු ටික අහගන්න පුළුවන්. Zoom may be a Zoom transmission of data. Like you cannot feel very smooth Zoom transmission sometimes. There will be lagging, sometimes there will be noise. Doesn't matter. That will not drop the quality of the entire service. But if it is email එකේ එනවා කැලලක් නෑ, වචනයක් නෑ, අකුරු ටිකක් නෑ, password එකේ අකුරක් නෑ. Then that is a big problem, right? Emails cannot use So emails like reliable service need to be used TCP, but unreliable service like video streaming, YouTube, then conferences can use UD. Understood? Which layer it is working? In this layer, transport layer. The network layer, there are packets. Internet protocol, addressing, ICMP, internet connection message protocol. That is where the ping request sent, ping ICMP, internet configuration message protocol. Ping request sent to ICMP. Then IP security, IPsec. Then here, point-to-point protocol, switches, bridges, Ethernet, routers. Routers are working here actually. Routers are working in the packet layer, right? Packets and routers have packets. But here data, switches, network switches are working. Network point-to-point protocol is working. Here PPP is point-to-point protocol, PPP. And then the physical layer is sending bits, wires, coaxial cable, fiber optics, wireless transmission, hubs, repeaters, sending signals. These are in the physical layer. Right? This is how the data sent. Application application data representation. So application or whatever we can see will be divided to data representation. It will be then like negotiation and connecting. So just connecting and creating the session. After creating the session, you need to select whether you need a reliable transport mechanism or unreliable, a fast or slow mechanism, secure or not secure mechanism. After selecting that, you can send it to the particular IP address. You are sending the message to that IP address. After reaching that IP address, you need to send it to the network, particular network. That is where the frames are there. After getting into the networks that will go to the wires. Then the signals will be sent to the wires. Wires in a signal will be taken from the switch, and switch will convert this to the particular IP, send it to the particular computer. That computer will understand, will assemble the packets, will collect the packets and assemble it here. After assembling packets, so after this negotiation is anyway there, after assembling packets, it will see what is there by the analyzing the representation algorithm. Then it will understand, and that will be prompted to your stream. This is the conceptual model of ISO-SI. The entire network lesson is here. Okay, I hope you got an idea, right? If not, please watch the video again, because this is very big part. ISO-SI model. I'm normally doing this 4 days. 4 days lesson I had to do just using a few hours, not even few hours, few minutes. Sorry, but I think you can understand this somehow. Just get an idea. Okay, anything unclear you can ask. MAC address will come in which layer? TCP is connection oriented. I have already given that here. Connection oriented. TCP is connection oriented. MAC address will come in which layer? MAC address is the physical address. Physical address will come in the physical layer. Physical layer, not physical layer, data link. Here, switch one and MAC address. MAC address is there in the switch. This one. IP address is there. There are IP address. Here you can see the IP address. IP address. Here you have MAC address. And there is an easy way of telling that. Some people will use that mechanism. They call this layer as application layer, and this layer as the network layer, and this layer as the internet layer, and this as a physical layer. That is called TCP/IP model. TCP/IP model. Let me erase this right now. If you want, you can just take a screenshot of this. Later you can watch this. So let's see and understand the questions now. Right. So this is called OSI, and the other model is TCP/IP. So these are two models. What will happen? Here in the TCP/IP model, this is better. TCP/IP model, application, presentation, session layer, all together we call them application. Transport layer is anyway transport layer, network layer is network layer. Then the network interface layer is the bottom layer or network access layer. Right? We call network access layer or network interface layer. That is how Second, this is another model, right? This is ISO OSI model. This model is called TCP/IP model. Okay, I have done more than required. Application, presentation, session together equal application layer. Transport is transport. Network is network, and the physical and data link layer will be treated as a network interface layer. This is how the TCP/IP layer works. Let's go to the questions now. Tell me the answer. In the OSI reference model, the network layer is responsible for communication. Which of the following suitable to fill the answer? Network layer is responsible for, yes. What is done by the network layer? Tell me the answer. Try to understand from the things that I have explained. Question number 8, you can send the answers. I didn't tell technical word, but you can think. I didn't explain the technical word here, but you can think. What is happening? Internet protocol. Internet protocol is basically identifying the source and the destination, right? So it is basically we call source and destination. Destination IP address, source IP address. IP address of the source, IP address of the destination. This is where this is where the destination and source is identified. So the answer is number 2. Which of the following indicate number of host bits in the IP address in class C network? Number of IP addresses respectively in class C network. Okay, class A network. So let me explain this quickly. Class A network. So there are 4 octets. First octet is class A network. Let me make it easier. Class A network. First octet. First 8 bits are for the network. This is for network. First 8 for the network. Then host, 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 and host. That is class A. Class B network. The first one is network. The second one is also network. Oh my God, this is class C. Oh no, class A, sorry. Class A. Network, then you have host. The next host is also host. This is class B network. And class C network, this is network. And the next one is also network. Next octet is also network. Network. This is our next one is also network. And the last one is host. So how many addresses are there? How many addresses are there for? How many bits are allocated for? What is how many bits are at following indicate the number of host bit and number of IP addresses respectively. How many bits are for the hosts in the class C? You know each octet has 8 bits. In class C, how many bits are for the host then? Yes. Class C net, class A network එකේ පළවෙනි address set එක network එකට. පළවෙනි bit 8. ඊළඟ bit 8 16 24ම host ලට. 24 bits for the host. Class B, first for the network, second for the network, 16 for the network, and 16 for the hosts. Class C network, 24 for the host, and next 8 for the, so 24 for the network, 8 for host. Then how many bits are for hosts? It is 8 bits, right? Last 8 bits for host. Then how many IP addresses? How many IP addresses? 8 bits. How many unique addresses? It is 2 to the power 8. What is 2 to the power 8? 8 bits will generate 2 to the power 8 unique addresses. What is that? Yes? I need your answer. Come on. It's lazy. 8 bits, 2 to the power 8 unique addresses means yeah, what is the value of 2 to the power 8?
256.
256. So what is the answer? Answer number?
8 and 200.
8 and 256. That is number. Okay, class B network. Class B network. So how many bits for the host? How many bits for the, how many number of, like, what is the number of IP addresses? Class B. Class B networks. Host la kiyada, network IP kiyada. Network වලට 16යි host ලට 16යි. host ලා කියන්නේ computers. Computers වලට 16ක් දෙනවා. 16 bits for the host, 16 bits for the network. 16 bits for the host mean how many unique IP addresses? 65,536. 65,536. That is for class B networks. 16 bits, 6500, 5000. මොකද දෙකේ 16 වෙනි බලය 2 to the power 16. Yes, 2 to the power 16. Class A network number of like networks තමයි අඩු. network එක host ලා ගන්න වැඩි. මේවා තියෙන්නේ මේ class based IP addresses are therefore based on the like network scalability, network size. දැන් මේකේ bit 8යි network වලට දෙන්නේ. bit 8යි කියන්නේ network තියෙන්න පුළුවන් 256. There will be 256 networks. හැබැයි එක network එකක host ලා තියෙනවා 8යි 16යි 24යි කියන්නේ දෙකේ 24 වෙනි බලයක්. 2 to the power 24 is closer to 16 million. ඒ කියන්නේ එක 2 to the power 6 කියන්නේ 2 to the 8 8යි 16යි 24යි. 24යි කියන්නේ 24. 2 to the power 24 means 2 to the power 10 is 1000. 24 2 to the power 20 is 1 million. Yes, around 16 million. Bigger number. ඒ කියන්නේ මේ network එකක computers ලක්ෂ ගණනක් දාන්න පුළුවන් එක network එක. So these are for giant networks, really large networks. එහෙනම් අපි පාවිච්චි කරන අඩුයි. We are not using them. Class B network for middle scale networks. Middle scale organizations go maximum up to 65,536. Theoretical maximum. එතන මේකේ network උත් තියෙනවා ඒ ප්‍රමාණය වගේ ප්‍රමාණයක්. ඒතර host ලා එක network එක host ලාක් දාන්න පුළුවන්. The class C network, I'll share a better video with this. Like we have discussed this in one of my individual classes. I think in Varun's class, I have just discussed. I'll share this video with you. So this class-based routing, I'll share this video with you. I'll send that video to your group, right? Then you can watch it. Because this part I couldn't discuss. If I try to discuss this today, then again the problem is the entire, I can only discuss one question. අපරාධනේ අපි දැන් අද ටිකක් questions වැඩිපුර යම් දෙක අඩු ගන්න පහක් පහක්. So you can see this. Initially we will slow down, but after that we will be very fast. So number this one is the answer. To each of the following network, class does the IP address 192.248. This belongs to which class? 192.268 belongs to. Yes, Varun can tell me the answer now, right? Because Varun was there in the class C. How that happened? I'll show this. I'll show the ranges. Then you can easily understand this. I'll show you the ranges. Otherwise, it is unfair because okay, here I need to open computer networks. Classless, class C, class A, class B, class C. Manchester encoding. Yeah, this is how the class ABC works. Okay. So take a screenshot of this. This is how the IP classes are working. If it is between 1 to 126, the first octet between 1 to 126, it belongs to class A. The first octet between 128 to 191 belongs to class B. First octet between 192 to 223, class C. Then 224 to 239, class B, and this. How this happened? Because the first octet categorization will happen like this. First octet කියන්නේ පළවෙනි එකේදී 000000012 000 0 1 1 1 1 1 1 0 වෙනකන් තමයි. This is the first set, right? Actually here, so the second class B එකේ 1 0 තියෙනවා. 0 0 0 0 0 0 2 1 0 එහෙමම තියෙනවා. 1 1 1 1 1. class C එකේ 1 1 0 තියෙනවා. 1 1 0 can 192. Then 0 0 0 0 0 2. Here 1 1 0 1 1 1 1 1 1. Class D 1 1 1 0 0 0 0 0 1 1 1 0 1 1 1 1. Class E 1 1 1 1 0 0 0 0 2. This is experimental. We are not using that class. So that is the octet changes. Those are the octet changes. 254. Sorry, the last digit should be 0. One 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 0 0 0 0 2 1 1 1 1 1 1 1 0. මෙහෙම මතක තියාගන්න. එතකොට ලේසි පොඩ්ඩක් ඔක් කැල්කියුලේට් කරගන්න. නැත්නම් අගයන් මතක තියාගන්න කියන්න පොඩ්ඩක් අමාරුයි. හරි. ඇයි මම මෙහෙම කියන්නේ කියලා කියන්නම්. 0 comes. So let me, here this one is fixed. මේ බිඳුව වෙනස් වෙන්නේ නැතුව අනිත් එක වෙනස් වෙනවා. මේක එකයි බිඳුව. 1 0 is fixed. Here 1 0 is fixed. Other bits are changing. This is the network portion. මම කතා කරන්නේ network portion එක ගැන. This is other portion is the first portion. 1 1 0 is fixed here. 1 1 0 is fixed here. 1 1 1 0 is fixed here. 1 1 1 0 is fixed here. 1 1 1 1 is fixed here. 1 1 1 1 is fixed here. Then do the calculations. Right here, the binary value is 1. එකේ ගොඩවල් නේ තියෙන්නේ. Binary value is 1. Again, 2024 binary lessons. 1. Here the binary value is 1 නැහැ මෙතන 1 ගන්නෙ නැහැ. 2 එකට reason එකක් තියෙනවා. This one is allocated for local host. මෙතනට 1 ආවොත් අපේ local host කියන IP category එකට වැටෙන්නේ. There you have to calculate 2 plus 4 is 6. 6 plus 8 is 14. 14 plus 16 is 30. 30 plus 32 is 62. 62 plus 64 is 62 plus 64 is 126. And this value is 126. This is how the 126 comes. Here 1 0 ne. මෙතන 128 ගොඩවල්. Then 128. Here 128 plus at this 1 plus 2 plus 3 plus 1 plus 3 plus 2 plus 4 plus 8 plus 16 plus 32 is 63. 63 plus 128 is 191. This is 191. This is 128. This is how the ranges are changing. Or you have to anyway, there is a descriptive lesson which I have discussed. I'll be sending that to the group. Well explained lesson about the IP classes. I'll be sending that to the group. Let's move to the next question. Take a screenshot quickly. Take a screenshot quickly. Anyway, you will be learning that leisurely in 2024 class, but the thing is like some of you are facing examination too early, right? So some are facing examination in 22. So recent examination. So therefore you will miss that. Therefore try to get that using, try to understand that using that. And if you really want, I can arrange you individual class, but that is not recommended because you have to pay high. So I have no option other than that because my time is really important to me. Can do that, right? If you have like time issue only, ඔයාලට වෙලාවේ ප්‍රශ්නයක් තියෙනවා විතරක් මට එහෙම කරලා දෙන්න පුළුවන්. But most recommended way is learn from the paper class and also from the theory class. Okay, take a screenshot. Done. Move into the question. So then you can see 192, 223. Here, what is the range? starting from 192 means when it is starting from 192, it belongs to the class C IP. In OSI reference model, a protocol data unit PDU of the network layer is referenced as network layer. What is the PDU in the network layer? Yes? You know the answer I just discussed. Then and then again, PDU in the network layer is
packet.
Packet, exactly. It's packet. Just discussed, right? Now, actually, we have how many days we have done the class? We have done 3 days. But within these 3 days, the knowledge that you have gained, if you watch the videos and if you refer them, the knowledge that you have gained is valuable than 5 months lesson. Masa pahaka lessons wage valuable. Hari me sati tume video balanda masa pahaka A level kara wage thamai. Man danno eka hard kiyala. I know this is bitter. This cannot be tolerated by an average student. Make average student කෙනෙකුට දරා ගන්න අමාරු වෙන්න පුළුවන්. ඒක වෙන්න පුළුවන්. I know that. But the thing is, we have discussed closer to 5 months lessons. මාස 5ක විතර lessons අපි කතා කරලා තියෙනවා. For average students, my recommendation is watch these videos again and again. And also, while watching the videos, go to my YouTube channel and watch the theory lessons also. There are some theory lessons. Then you will understand this. You have to work hard because you are the one going to face the examination ultimately. I can't write for your examination. I can't do like that. Right? Cannot do like that. Right? You are the one who facing the exam. But don't just think about the examination. Think about the value of the lesson. The value of this lesson, baby, this is lifetime valuable. මාස පහක් නෙවෙයි ඔයාලා මේ ඉගෙන ගත්ත එක ඇත්තටම සාමාන්‍යයෙන් 5 million විතර ඉන්වෙස්ට්මන්ට් එකක් ඒ මාස පහ. මොකද ඔයා මේ මේකෙන් කවදා හරි හොඳට උපයන ජොබ් එකක් කරන්න ඕන ෆවුන්ඩේෂන් එක හදාගන්න. If you learn this very well. මේක note down කරලා තියාගන්න. Put an asterisk somewhere and note down here. This time 2022 October 1st I said in the Children's Day I said this. This is 5 million worth investment. If you came these 3 days. Right, and actually learn that. That is the thing, right? There's an if condition. If you really learn everything that I said, if you really learn that is 5 million investment, definitely you will reach pinnacles of your career one day. You will reach the highest, great heights in your career one day. So if you really understand the concept and the link between these lessons, definitely an investment. Right? Therefore, you are better. You are doing very well, right? You are doing very well, and you have selected proper channel. You have selected proper subject. I think you are gaining knowledge from a proper teacher. So if you go through and if you work hard, definitely you will get that advantage. Question number 12. Which of the following correctly list the given computer storage components in descending order of access speed? Descending order of access speed. Okay, this is about the memories. These memories are similar to our memory. So some memories are in our processing unit, brain cells. The memories in the brain cells are really super fast. Even before think, it can act. Hitannat kaling act karanna puluwan taram fast. So you know, I think you have learned about something called, I cannot remember the English wording, but that is called pratika kriya in your science lesson. I cannot remember the exact. That is like you are without thinking, you do some actions, you take some actions. For an example, if you feel fire, ගිනි කූරක් හරි ගින්දරක් තියෙන තැනක අත ගෑවුනොත් මොකද වෙන්නේ? හිතන්න කලින් අත ටක් ගාලා යනවා. කරන්ට් එක අත ගෑවුනොත්, if you touch current, before you think, your hand will move out. නේද? කරන්ට් එක වදිනකොටම හිත ඉන්නවද මොකක්ද ඒ වැදුනේ මට? What did I feel? Is it there? So what is there? Are we thinking of we are moving the hand out? When there's a fire, we are moving out away. So that is even before thinking. That kind of fast memory is there in the computer processor. That is called registers. Super fast memory. Inside the registers, inside the processor. And then to support that, to back that, to support that, there is another memory inside the processor that is called cache memory. Whatever you are processing will be moved to the cache memory. Whatever you are doing now, currently doing, is there in the main memory. That is this PDF document and this Zoom session now in the main memory or the RAM. මේ Zoom session එක, මේ PDF එක, මේ screen එකේ display වෙන මේ interface එක, මේ icon set එක දැන් තියෙන්නේ RAM එකේ. So that is in the main memory. And it was there, it is actually permanently saved in the magnetic disk or magnetic නෙවෙයි දැන් SSD වෙන්නත් පුළුවන්. It can be even SSD disk. But SSD is faster than magnetic, right? Remember that SSD is faster than magnetic. Anyway, that is secondary storage. Secondary storage is holding this memory for long time, keeping this memory for long time. That is secondary. Keeping for long time, secondary, forever. Until we delete or until corrupt. It will be there in the secondary storage, hard disk, CD, DVD, pen drives, memory cards. It will be there permanently. That is secondary storage. After that, currently accessing data or information that is in the main memory. That may well have access kind of snapshot taker. Everything there is main memory. Currently processing things are there in the cache memory. And while processing, it is there in the registers. Right? That is the simplest way of expressing. Long time, it is there in the secondary storage. Long time storage is your secondary storage. Then currently accessing data instructions are there in main memory or the random access memory. Currently processing data and instructions are there in the cache memory. And while processing, it is there in registers. Here answer is what? What is the answer? Which of the following descending order? Descending means of access speed. Descending order of access. Ascending කියන්නේ access speed වැඩි වෙනවා. Descending, it's moving down. So what is the descending order of access speed? It is descending. Descending means speed will be lower. Access speed will be lower, descending, starting from high to low. High to low. Registers, cache memory, main memory, magnetic. That is answer number 4. Answer number 4. Yes, answer number 4. Descending means access speed, high speed to low speed. High speed to low speed. High speed is register. The low speed is magnetic disk. High to low. Understand the descending order. Ascending order other way. Okay, I think. Let me show. I think we had some lesson. Not sure. I'll show it using here. There is something called memory hierarchy. There's a pyramid. And this shows entire picture. So here CPU registers, cache memories, there are different levels like cache memories, level 1 cache, level 2 cache, level 3 cache, like cache memories are there. Here you can see this. This is in the cycles, but I don't see. I need more detailed one. Let's have in more details. Yes. Let's have in more details. Let's move to the page. Oh, something there. Okay, Dasun. Yeah, this is, take a screenshot of this. This is detailed version of that. There are 3 levels of cache: level 1 cache, level 2 cache, then the physical memory, random access memory, and this can be SDRAM, DDRRAM, or DRAM and all. The flash solid state memories are there, SSDs, memory cards and all. Then the virtual memories and the hard disk file based memories. Then after that, even the network memories come in even after that. That is the full snapshot of the memory hierarchy. Okay. Right, let's go to the next question quickly. Consider the following computer memory types. What are the volatile memories? Volatile memories, basically, volatile volatile memories are, yes, addressing thing I'll explain. So I'll explain with the question. I'll definitely explain with the question. There are like physical address, virtual address, translation, frame numbers, and all. I'll explain that, but hold for the moment. Otherwise, what will happen? We are not going in the order, right? We are going into the order according to the order. Doesn't matter. Like I'll explain. Okay. Consider following computer memory types: CMOS, cache, flash, hard disk, RAM, registers. Volatile means voltage, depend on the voltage. Voltage depend on the voltage. Which of the following depends on the voltage? Which is actually another way of asking the same question. Which of the following are temporary memories? Which of the following are temporary memories? Temporary. Flash memory, hard disk, flash memory, hard disk. These are kind of these are kind of, and CMOS memory. Right. CMOS, you can say that without the battery it will not hold, but we can consider ROM, basically the ROM, read-only memory. So here actually what they have referred it ROM, read-only memory. A is kind of permanent memory. Cache memory is temporary, that will be erased. Cache memory is temporary, that will be erased. Then flash memory is basically for these SSDs and all, flashable memories. These are flashable, but the thing is, if the memory will be kept for some time. Flashable means erasable, but it is not erasing with the power. When power goes, still the flashable memory will be there. Like these, especially these flashable memories are there in microcontrollers and memory cards also. These flashable memories are there. So that is also kind of permanent, not volatile. But cache memory is volatile, depend on voltage. Hard disk is anyway permanent, you know that. Random access memory is, DRAM, SRAM, both are impermanent. Those are volatile memories. So E is also an answer, and registers definitely so volatile memory. Currently processing, currently accessing. These things are volatile. So we can say B, E, and F. That is answer number 4. Correct. Answer number 4. Right. Oh, that is our next lesson. So actually, this is one of the biggest lesson again. So that we need to discuss, that is basically HTML. But for the moment, just try to answer the questions. Doesn't matter if you don't know. Keep it blank or guess. Guess Guess question number 14 and 15. Guess and send the answers. If you know the answer, send. Right, the first one, HTML frames are used to divide browser window into multiple sections. The rows suitable for frame set tags are defined the number vertical frames and the frame set calls 100, 500, 100. Create a vertical frames. Calls means columns. Columns are vertical frames. Specified number of millimeters. No, it's not millimeters, it's in pixels. Pixels. The HTML frames are used to divide browser window into multiple sections. Yes, true. Frames are in browser window. I'll explain that. I'll show that next day, right? Practically. Don't worry. I will do that practically and explain you. Then the rows attribute in the frame set define the number of vertical frames. Rows vertical. That is also correct. So you can say A and B are correct. Sorry. The rows attributes of frame set tag define the number of vertical. No, it's not vertical. It is horizontal. It is horizontal, not vertical. Vertical can horizontal, right? Rows attribute is horizontal. It's not vertical. So then B is also wrong. Then A is only the correct answer. Means like 1 is the correct answer. Yes. So what's your answer? First, yes. 1. Then consider following and replacing 1 and 2 and 3. 1 is a list, no? But you can see this list is not a normal list. This is not a bulleted list, or this is not a numbered list. Then what is this list? This should be a definition list. So 1 is DL. DL. Is there a DL here? Either 2 or 5 is the answer. Then the definition term DT. 2 is DT. Then the second one is definitely the answer is second for the question number 15. Okay, I'll explain this practical part. Right? I'll explain this practical part and discuss this HTML practical questions next day. Then I'll stop from here. Good night. See you all next week.